let's take our understanding of the real number system and all the subsets that are a part of it to complete the following exercise set. We're asked to determine the number sets of the given values, identify which number set or sets to which it belongs, mark an X in the corresponding boxes. So let's start first. And we have -6. And I've stated in the previous video of this lesson that we need to figure out the first place this number existed. And so if we take a look at -6, it's not natural because it's not one of your counting numbers. It's not whole because whole includes the number 0 and then all your counting numbers. First place it starts is an integer. So it is an integer, which also makes it rational. And if it's rational, there's no way it's irrational. And then we also know it is a real number itself. And so we have those. So integer, capital Z, rational, which is a capital Q, and real, which is a capital R. If we look at number 2, you see 0.33 with the 33 bar above it repeating. So this is a repeating decimal. So there's no way it's natural because it's not counting. Not the number 0 or a counting number, so it's not whole. It's not a positive, negative whole number. Is it rational? If we think about it, is a repeating decimal rational? And yes, it is. And so it is a rational number because it is a repeating decimal, and the definition for rational is a repeating or terminating decimal. So it's rational and real. Remember, if it's rational, it can't be irrational. 27, if you were to count 1, 2, 3, 4, 5, skip all the way up, 25, 26, 27, it's a counting number. It starts with the natural number set, which means it's also a whole number and integer, and it's rational. It can't be irrational, and it's also real. So if it starts in the natural number set, it belongs to all of them except for irrational. 0 is not one of the counting numbers, but it does start at the whole number because whole numbers are 0 and then your counting numbers. So it starts in the whole, which means it's also an integer and rational and real. And then we have the square root of 19, which if you were to look at the square root of 19, it's going to be 4.358 ... This is a non-repeating, non-terminating decimal, which means it's only irrational and real. If it's irrational, it can't be any of the other ones for it. But don't go under the impression that if I have a radical, it's going to make it automatically irrational because the square root of 36 is the number 6 itself. So though it's written like a radical, it can be simplified into, well, 6 is a natural number, a whole number, an integer. It's also rational, and it's real for it. And so you can see here these 6 examples identifying all the subsets which they belong. Understand to find where it starts first, and then move on from there to figure out the rest of the subsets.